The surface treatment center we would like to present to you today takes us to the medieval town of Chudym in the Czech Republic, where a future-oriented industry focused on wind energy has established itself just a stone's throw from the city's historic gates. Here, the internationally active company SIAG manufactures the towers and mainframes for wind turbines. SLF supplied 2 blast units, 2 complete coating lines and a free space coating station for SIAG. This film will present the processing steps that can be seen in the new surface treatment center. Once the prefabricated tower elements arrive on flatbed trailers, they are unloaded using the indoor crane. The 2 large telescoping spray cabins are the first thing to catch the eye of a visitor to the center. The cabin dimensions were adjusted to accommodate processing of the largest workpieces that are treated here. Hello and welcome to the paint and coating shop at SIAG AG in Chudym. Here we apply the surface coatings to the towers used in wind turbine power plants. The first step in this process is the cleaning of the surfaces in the blasting cabins. This is followed by the application of coatings in these spraying and drying cabins. We can process workpiece segments with a maximum length of up to 35 meters. The current workpiece diameters are about 4.5 meters. The work we perform here is guaranteed for a period of 5 years. Carbon filters have been installed downstream of the coating lines, which means that we can already fulfill future emission restrictions. The process begins with the blasting of the workpiece surfaces. 2 blast cabins with identical dimensions are available for this purpose. The workroom's internal dimensions encompass a length of 38 meters, a width of 7.5 meters, and a height of about 6.5 meters. The workpieces enter the blasting cabin on rail cars. These drive units also make possible the axial rotation of the tower elements. Two workers wearing a full complement of protective clothing implement the manual blasting process. Rust, scale and burrs are removed using steel shot as the blasting abrasive. At 650 lux, the workpiece is very well illuminated from the side and from above, making it possible to continuously evaluate the workpiece surface. 2 pressure pots are used, each with a capacity of 200 liters. Blasting hoses with lengths of 40 meters facilitate all of the required work positions. The 12mm blasting nozzle operates at a pressure of about 6 bar. The extraction ducts, which are installed at staggered locations in the interior of the cabin and protected behind impact deflectors, remove the dust-laden air from the cabin. Fresh air enters through the roof. In order to give workers a continuously clear view of the workpieces, 90,000 cubic meters of air must be circulated and filtered every hour. 6 fan units, each rated at 18.5 kilowatts, move the exhaust air from the machinery room to the cartridge filters. The blast cabins located to the right and to the left have their central connection points here. Because the machinery located here is used to simultaneously supply both workstations, the required machines are arranged in what is almost a mirror image configuration. Impurities from each group of 3 filter units are continuously deposited in big bags. About 85% of the volume of air can be returned to the blasting cabin. When cleaning the insides of the tower elements, workers must make use of additional portable light sources. Once a blast cycle of this type is completed, the steel shot that has collected inside the pipes is blown out of them. Stopping the flow of abrasive makes it possible to use the blasting nozzle for this purpose. When the blasting cabin is empty again, the expended steel shot must be returned to the process loop. Because the surface area here is quite large, SIAG decided against an automated solution using screw or scraper conveyors. Instead, the solution implemented here uses a forklift equipped with a plow attachment to clear the workspace of blast media in just a short period of time. At the end of the blasting cabin, a conveyor located beneath the 7-meter-long floor grate transports the shot to a bucket elevator. In the upper part of the installation, the abrasive passes through a cleaning station before being returned to the storage silo. A manually operated blasting cabin can be used in many ways. Today, for example, brakes in the processing of tower components are used to blast welded components and these massive turbine mountings. Because SIAG offers a comprehensive warranty on the wind turbine components that it manufactures here, all of the processing steps are continuously monitored. This gives us a good opportunity to take a closer look at some of the details of the workspace. All of the walls and roof surfaces are completely protected by a wear-resistant rubber lining. An additional wire mesh cover also protects the 24 dust-tight floodlights. In this rear view, we can see that the blasting house without the overhead crane requires only a modest overall height. Now let's take a closer look at the coating process. The introduction of our telescoping cabins was an outstanding innovation with respect to the coating of large workpieces. In this case, the SLF cabin extends to the appropriate length in order to cover the waiting tower section. The housing's individual cells consist of double-walled insulating panels mounted in extremely stiff frame elements. Rows of brush strips ensure that no abrasive escapes through the junctions in the telescoping cabin. The ventilation unit is designed primarily as a vertical system. To accomplish this, 10 long-range nozzles are installed in the roof elements, and these nozzles introduce filtered and pre-warmed air on a segment-by-segment basis. Control of the system is accomplished using volumetric flow controllers and pneumatically activated shutoff valves. When coating interior surfaces, a longitudinal ventilation system is of course essential. In this case, the control system opens the ceiling air inlets on one side of the cabin while opening the floor flaps on the other side of the cabin. An additional venturi nozzle located at the pipe entrance supports the flow of air inside the pipe. The coating technician sprays the pipe with a broad back and forth motion, and depending on his progress, a helper pulls in the air and coating hoses. The dimensions of these workpieces make it necessary to divide the spraying process into top and bottom halves. SLF's proven impact separator extracts the contaminated air emitted from the workpiece. The impact surfaces collect and retain as much as 70% of the particulates in the exhaust air. The coating mist passes through a downstream filter, bringing the overfiltration efficiency to 97%. The two-stage cleaning system results in a filter mat service life that is significantly longer than that usually possible in conventional grated floor systems. The fresh air is sucked in through a pre-filter stage by a centrifugal fan and then warmed to 20 to 22 degrees Celsius by an air heater. The installed air handling capacity of 50,000 cubic meters an hour can be activated in segments. The long-range nozzles only feed fresh air to those areas that require it. This energy-saving concept has proven itself many times in installations designed to process large workpieces. By way of comparison, coating the exterior surfaces is quite a comfortable process for the operator. Thanks to the rotating drive, the target surface revolves past the operator. The completely uniform lighting strength of more than 800 lux and the air's vertical settling speed of 0.3 meters a second facilitate the work. After each rotation of the work segment, operators are required to check the coating thickness. Experience and the ability to concentrate are absolutely necessary to achieve the required level of quality. The maximum coating throughout for this cabin is calculated to be 50 kilograms an hour. During the flash-off times between each of the coating layers, a special purge air circuit can be used to force the removal of the solvents. To facilitate the drying process, the cabin is placed in a zero-pressure state and switched to recirculation mode. Only a portion of the airflow, amounting to 5 to 10%, is replaced by fresh air during solvent removal. The drying temperature in the cabin is now about 50 degrees Celsius. After the drying time is over, the telescoping dryer returns to its home position. Once again, this illustrates the handling advantages. The indoor crane has direct access to the workpiece for the loading process. The telescoping function makes it possible to achieve space savings of 40%. The transport process will certainly start soon, since this is the last time the coating thickness will be measured. At this point, we would like to show yet another workstation. In an adjacent part of the hull, a free space coating station was installed to accommodate workpieces with a wide range of dimensions. The motor and turbine platforms supplied with the towers by SIAG are prefabricated here and equipped with various components. Because it's located immediately next to the assembly area, a coating station of this kind makes it possible to take into account workpiece-specific requirements resulting from, for example, the masking of workpieces. The 10 long-range nozzles were installed here in a way that preserves the full functionality of the indoor crane. The useful ventilation-related area here measures 14 by 7 meters. Depending on the workpiece, 4 sections can be activated. The pre-warmed fresh air reaches the coating technician in a precisely targeted way and removes the contaminated air from the hull. The flow behavior has been calculated in such a way that the air volume of 50,000 cubic meters an hour is circulated in an extremely small space, leaving the adjacent workstations completely unaffected. Only the coating throughput rate is limited to 25 kilograms an hour, a quantity that will only occasionally be considered restrictive given the types of workpieces that are processed here. The in-floor extraction system implemented here also uses the heavy-duty impact separator developed by SLF. Beneath the U-shaped profiles, which interlock like a labyrinth, we see the film surfaces that are used to collect the dry coating residue. Everything that collects here can no longer collect in the downstream filter cartridges, which is a very important economic factor. Before the exhaust air can be released into the skies over Chrudim, it passes through the automatic filtration units located outside. A coating and paint shop has predetermined emission limits. The exhaust air is permanently analyzed. We can read the measured values on this panel. Here we can see which unit is currently in operation and which filter is operating. The individual filters are filled with activated charcoal, which continuously captures harmful emissions. When the filters are saturated, the system automatically regenerates them. Here we see the incineration of the exhaust gas, which removes the contaminants. This completes the regeneration of the filters. When will you use our know-how to boost your productivity?